She tried really hard.
Okay, back in chapter 5, we went over simplifying expressions, and so I'm going to go through a couple of these from the worksheet and making sure that I pay attention to the operation. So the first problem, a to the fourth plus a to the fourth, the operation is addition. So to add a to the fourth and a to the fourth, I've got 2a to the fourth. Notice again, it's just the same thing we did before with adding like terms. The exponent does not change because you're just asking how many a to the fourths do I have. Similarly, in part E, a to the fourth minus a to the fourth, well, I know that anything subtracted by itself is going to be 0. No a to the fourths. Then we went on with the rules of exponents, and when we multiply a to the fourth times a to the fourth, when we multiply those when you multiply the bases, you're going to add the exponent. So this would be a to the 4 plus 4, which is a to the 8th. And so that's some of the work that we did in chapter 5. I'll let you go through and work the rest of these and check your answers, but I am going to skip to part G because that's where we have some negative exponents, and where the hello, there's another nice big arrow. We don't want that. But a to the fourth over a to the negative fourth. A negative in the exponent means you are to take the reciprocal. So if the base of a, I'm going to try to see if I can get a better looking arrow. Where's a better looking arrow? No, it's not going to happen. I forget. Okay, I'll try to figure it out. But the a to the fourth in the numerator stays a to the fourth, and then the a to the negative fourth is going to come up to the numerator as well. So this would be the same as a to the fourth times a to the fourth, which what we saw in part B was a to the 8th. So your rules of exponents are worked here, and then you can see the answers on the document in the document sharing. On problem 2, we now multiply, rather than multiplying monomials, we're going to multiply polynomials. And in the first one, we've got a binomial here, 2 terms, binomial, times this is a trinomial because there are 3 terms, 1, 2, 3. Remember that terms are always separated by plus and minuses. So to simplify this, we're going to use the distributive property. And so we're going to take the 2x factor and multiply it, distribute it to the x squared, then distribute it to the 3x, and then distribute it to the 2. And so we're going to multiply those. We're going to get 2x times x squared plus 2x times 3x plus 2x times negative 2. And I will pause now because the clippers just did something cool. Hold, please. Okay, it was just Blake Griffin with a good slam. So now the next step is to take the 3 and multiply it to the x squared, the 3x, and then negative 2. I'm running out of room, so forgive me. I'm just going to continue on the next line. So plus 3 times the x squared plus 3 times the 3x, and then plus 3 times the negative 2. And then from there, I'm going to have to clean all this up. And so the 2x times the x squared, when you multiply the bases, you add the exponents. So 2 plus 1 will be x to the third. So I've got 2x to the third. And in the next term, I'm going to have 6x squared. And then 2 times negative 2 will give me negative 4, and then the x, negative 4x. Then I'll have 3x squared, again running out of room, my apologies, plus 9x, and then minus 6. And the last step, after I've multiplied everything, the next step is to add all like terms. So I don't have any x to the thirds other than the 2x to the third. So I'm going to have 2x to the third. I've got a 6x squared here and a positive 3x squared there. So I'm going to add 9x squareds. And then I have a 4x and a 9x. Sorry, that's a negative 4x, isn't it? So that's going to leave me with plus 5x and then minus 6. And now this is in simplified form. Again, pausing for my husband liking the Clipper game. And we're back. So one thing I wanted to make sure we understand about the beginning and the end of this problem. At the end, this form here is a polynomial in simplified form. It's very important to know the difference between simplified form and factored form. So notice in simplified form, there are no like terms. We can't do any of the addition or subtraction. No other operations can be performed. And again, each term is separated by a plus or a minus. So we've got 1, 2, 3, 4 terms in the simplified form of this polynomial. On the other end of that is the original polynomial that we have up here, the original problem. Up here is that same polynomial, but this is the polynomial in factored form. And notice in factored form, the main operation that you have, the main operation is multiplication. You're multiplying a prime polynomial and another prime polynomial. And that's going to be factored form. So these two expressions up here, the factored form and the simplified form, these are the same polynomial, just written in different forms. I like to say that they're the same person, and this might be their real name, and over here this is their nickname, but they represent the same thing. So you can use the distributive property on B, C, and D and check your work with the answers in the document sharing. So once again, in problem number 3, we're trying to simplify what we did in chapter 5, but we're going to pay special attention to what our result is. So in A, again, I've got two polynomials, x plus 2, being multiplied together, x plus 2 times x minus 2. And so this is, again, like I said before, this is what's called factored form. The x plus 2, x minus 2 is factored form because these are both prime polynomials being multiplied together. Now, to simplify it, I'm going to use the distributive property. And so I'm first going to take the x, this x, and multiply it to the first x in the expression x minus 2, and then that x times the minus 2. So we'll have x times x plus x times negative 2 plus 2 times x plus 2 times negative 2. Again, my apologies for the spacing on this. And now when I do the multiplication, I get x squared minus 2x plus 2x minus 4. And that gives me, now I add the like terms, and we've got a like term of negative 2x plus 2x. That's going to give me 0, and I'm going to be left with x squared minus 4. And again, this is what we called simplified form. So the simplified form is x squared minus 4, and that is the same thing as x plus 2 and x minus 2. You might want to try it. Plug in something for x, like if I plugged in 0 for x. Over here, if I plugged in 0 for x, I would end up with 0 minus 4, which is negative 4. And over here, I would end up with 0 plus 2, which is 2, times 0 minus 2, which is negative 2. And 2 times negative 2 would give me negative 4. So same polynomial, just different names, nickname and the regular name. So as you work these, you should notice a pattern. And if I were you, I would pause here and work the problems and see if you see a pattern in all your answers, and then see if you can shortcut it. So pause your computer and then join me in a bit. Thanks. Okay, welcome back. I did some of the problems and simplified them, didn't show the work. You can see that on the document uploaded in document sharing. But notice, we want to take some look at some patterns. When I simplified the x plus 5 times x minus 5, I ended up with just two terms, x squared minus 25. And if you look at all of these, you always end up with two terms. Now these two binomials, the 3x plus 4 and the 3x minus 4, those are called conjugates. They're not opposites, because an opposite, the 3x here, the opposite would be negative 3x. So they're not opposites, they only differ by one sign. And anytime you multiply two conjugates, you will end up with a binomial. So for all of these, we end up with two terms in the simplified form. Even better than that is, notice all of these terms have a minus, and all of these polynomials have a minus in between the two terms. And then also, the first term is a perfect square, x squared. This would be the quantity 3x squared, right? 3 squared times x squared again, 4 squared times x squared. And notice the last term is also a perfect square. 25 is 5 squared, 16 is 4 squared, 9 is 3 squared, and so on. So this is why the simplified form is called a difference of squares. So the squares are on the outside, and you take the difference of them. So now in chapter 6, when we're factoring, if you see a polynomial with two terms in simplified form, and it's a difference of squares, you can factor it by writing the two conjugates that are the square roots of those terms. On number 4, we're looking at perfect square trinomials. So notice here, the two binomials that I'm multiplying are the same. So when I do use the distributive property, I'm going to get x times x plus this x times that 3 gives me 3x, and then plus another 3x, and then a 9 at the end. When I clean this up, I'm going to get x squared, and then the 3x plus 3x will give me 6x, and then plus 9. So notice when I multiplied these two binomials, I ended up with 3 terms in my simplified form. So again, this is the simplified form, and up here is the factored form. Go ahead and work a few of these. Actually, I'm going to skip it. I'm going to show you another one here. Be careful with f. A lot of people forget that the base of that square is the whole quantity x plus 8. So when you see this, a lot of people just want to square the x and square the 8 and be done with it. But it would be good practice to expand that. This is actually saying x plus 8 times x plus 8. And then you'll see that there's a little bit more involved. You've got to multiply the x's and then multiply the x times the 8. So you're going to have a couple more terms than you would have had if you had just squared the first and last term. So when you simplify this, you'll end up with x squared plus 16x plus 64. I skipped some steps there. You make sure you can fill those in and see that. And go ahead and finish some of these other ones. Push pause on the video. Welcome back again. So I did some of the simplified, some of these perfect square trinomials, and let's take a look at what we notice. All of these start with a square in the first term, x squared, and then all of them end with a square. Notice 9 is 3 squared, 25 is 5 squared, there's where we got the 5s, 16 is 4 squared, and notice all these terms at the end are also always positive. The 100 is 10 squared, the 64 is 8 squared. But then what's up with the middle term? The middle terms Remember, your original binomial here was 3, and the middle term is 6. The original binomial in here had a 5, and the middle term is 10. And that's a positive. It looks negative, but it's a positive. Positive 10. Here we had negative 4, and the middle term came out to negative 8. If you look at the pattern, this middle term is always twice that negative 4 there, twice the 5 here, twice the 3. So if I know I'm going to be multiplying over here x minus 1 times itself, I know the first term is going to be the x squareds. The last term is going to be the positive 1. Negative 1 squared is 1, and there's my positive. And then the middle term is going to be that negative 1 times 2 times the x. And that can help make things shorter for me. But again, the important thing to notice is now in Chapter 6, we're going to work backwards. You're going to start with the simplified form here, and you want to work your way back. So you've got to recognize these patterns. I've got a square in the front, a square in the back, and that square is 4 squared, and that 8 is related to 4. It's double that 4. So good things to notice for Chapter 6. And again, make sure you know the difference between factored form and simplified form.